decided to do our project over capsaicin. My name is Madison Sprecher, and I'll be talking about the hydrophobicity and the basic uses of capsaicin.
I'm Lindsay Blanchett. I'll be talking about the pharmaceutical use of capsaicin and how it's used on the body.
I'm Carlos Gonzalez, and I'll be talking about how we rank feelers based on their spiciness.
I'm Clara Selke, and I'll be talking about the general structure of capsaicin, as well as a similar molecule found in wasabi. So a few of the functional groups in capsaicin that we've become familiar with are an aromatic ring, ether, and hydroxyl, which together form a vinyl group. Vinyl groups are also found in vanillin, which are responsible for the taste of vanilla. It also contains a carbonyl next to a nitrogen, which make an amide. The capsaicin receptor is the TRPV1 receptor. It's responsible for detecting and regulating the body temperature. When it's activated, it gives a painful sensation. It is activated by heats over 43 degrees Celsius, acidic conditions, and capsaicin, of course. Sensitivity can change with conditions. Inflammation from tissue damage will increase sensitivity of that receptor, while prolonged exposure to capsaicin will decrease it. So if you have spicy stuff in your mouth for a long time, your mouth will get number. There's also a thing called capsaicin, which is a competitive antagonist, which means it reversibly binds the receptor and reduces the number of capsaicin molecules that bind, so it makes things less spicy. Capsaicin is found in peppers, also known as capsicum. Birds are best for distributing the seeds, so the plants would prefer for the birds to eat the fruit and not us, because mammals like us chew on the seeds and destroy them and keep them from germinating. Capsaicin doesn't trigger the bird's TRPVN receptors, while they do trigger ours, so capsaicin gives us a painful sensation, but not birds. This is advantageous to the plant's reproductivity because it promotes spreading of the seeds from the birds.
So the basic structure of capsaicin is hydrophobic, and as the name implies, it does not like water. This is because water is polar, and capsaicin has a long non-polar tail. Now there's two reasons why milk soothes the pain after you eat spicy food. The first is that there's fat contained in milk, and it also has a non-polar tail. So, like dissolves like. The capsaicin gets absorbed by the milk fat and gets washed away. The second reason why milk dissolves capsaicin is because it also contains a protein called casein. Now this can be similar to the soap and oil analogy like it was used later in real life Orgo. Now the milk is like the soap and the capsaicin is like the oil. The center of the casein micelle is hydrophobic, but it has protruding tails that are hydrophilic. The capsaicin gets dissolved inside the head of the casein micelle and gets washed away.
Allyl isothiocyanate is a similar molecule to capsaicin in that it gives us a painful sensation. It's found in mustard and wasabi, and it also activates the same receptor. But unlike capsaicin, it's hydrophilic, so it's a more short-lived pain because it can get washed away more easily. Like capsaicin, it's a plant defense mechanism against hungry animals.
Okay, so the Scoville scale was a scale that was standardized, that was made by Wilbur Scoville in 1912. This scale was used to rank chili peppers in terms of their hotness or spiciness. This was a concentration of the amount of capsaicin that was in it. This process was done by diluting the chili pepper with sugar water. Around 1 million drops of sugar water raised the Scoville unit by 1.5. And you had to dilute the chili pepper enough to not be able to taste it anymore, so they had a panel of human tasters. Capsaicin in its purest form is around 15 million Scoville units. To put that into perspective, the hottest pepper that we currently have is around 2 million Scoville units. That's a Carolina Reaper, if I recall. And put that into more perspective, jalapeno is something that we associate mild spiciness with. It's a mildly spicy pepper. Is only around 4,000. Okay, so notice in the last slide I was talking about capsaicin or Scoville units in estimation. I said around 4,000, around 15 million. That's because the method of using dilution with sugar water is relatively inaccurate because the panel was made up of people with different tolerances to capsaicin. So every single person would have different units for them. So nowadays what we do is high performance liquid chromatography, and this is no different from regular paper chromatography. We use a solvent with the mixture, we put it through a column, it has different retention times, and we measure that. But with high performance liquid chromatography, we use a solvent with the mixture in it. We put it through a column with a solid phase in there, and we measure it with high pressure and measure the retention time that it goes through with the detector. And then it goes to a chromatograph, and you can read that as it's plotted over retention time. And a scientist can then read out the results for capsaicinoids and also homocapsaicin. Homocapsaicin is an analog to capsaicin. An analog is a compound that is really similar to the compound that it is an analog of, but it has a different structure, different properties. But in this case, homocapsaicin is less potent than capsaicin.
One of the practical uses of capsaicin is its use as a topical ointment for pain. Besides the self-named cream, the commonly known Icy Hot works in a similar manner to capsaicin, but it contains a different active compound. Capsaicin is used to relieve pain from pain disorders, nervous system problems like shingles, cluster headaches, joint problems like arthritis, skin conditions like psoriasis, and mouth sores due to chemotherapy or radiation. The capsaicin works by binding to TRPV1 in the skin, which is the transient receptor potential vanilloid 1 that detects heat of 107.6 degrees Fahrenheit or above and acidic pH levels. The actual activation of the protein by capsaicin has not been studied completely, but the binding involves altering the protein conformation by changing amino acid residues due to intermolecular interactions with the capsaicin molecule. And more specifically, its more polar functional groups, which alter the intermolecular interactions of the protein's amino acids. The pathway that follows this binding sends substance P to the brain to indicate that there is heat at the location of contact. This is what gives the illusion of heat when creams containing capsaicin are applied to the skin. The benefit to using this type of cream is that the body only has a certain amount of substance P in it, so the signal of this compound will run out after long exposure to the stimulant. This means that there will be an initial tingling or burning sensation when the cream is applied to skin, but after a few minutes, this feeling will subside, and you'll not feel any pain at this spot anymore. Essentially, by overexposing the receptors, they become chemically exhausted and can no longer send a signal of calcium ions to the brain saying that there is pain.
Capsaicin is also found in dietary supplements. Now, these supplements are not regulated by the FDA, so it's very common that they're not tested, so they're not very reliable. But it's found to improve digestion because it increases your stomach fluids to help digestion. It also is found in antioxidants, and it helps protect against free radicals in your stomach. And it also prevents bacterial infections as well as diarrhea that is caused by bacterial infections. And the last way it is used is in weight loss because it increases your metabolism. Believe it or not, there's still more things this thing can do. It is also found in wildlife control. It was first used in 1962 and is regulated by the U.S. Department of Agriculture. Now, the main thing it shoos off are deer, voles, rabbits, rodents, and insects. And surprisingly, birds are immune to it, so it's very common to crush up dried chili powder that capsaicin is found in and mix it in with bird seed. That way the bird feeders can still be used, but rodents don't get into your bird feeder. It is also found in rural African communities, and here it is used in crop control so insects don't get into it and pests don't get into it. And it is protected by the Elephant Pepper Development Trust. It is also used in pepper spray, and this is used in riot control and personal defense and attacking dogs and stuff like that, and it's very common to carry it around with you. And the reason why it's found in pepper spray is because when it comes in contact with skin or mucous membranes, it causes a burning sensation and it's very hard to breathe. And the last thing it is used in is equestrian sports, but it recently just got banned because of its hypersensitive property, and it was first used to spray the horses so their limbs become numb and so they're faster. But it's banned now, and actually in the 2008 Summer Olympics, there was 4 horses that tested positive for pepper spray, and they were disqualified.